everyone. My name is Tal, and thanks for joining Bilu Software That Scales with TypeScript. So most of you know TypeScript. Looks like it. I'll probably not introduce many TypeScript things you don't know, but just as a show of hands, how many of you do backend development? Okay. Front end? Okay. And I don't know, off the front end, how many of you are full stack? Okay, so that's pretty good. Okay, so as I said, my name is, I'm manager in Amazon as of last week. And is it okay, the mic? I'll continue talking. I'm into clean code and functional programming and software design, and we'll touch on all of them in a minute. What is TypeScript? Basically, it's JavaScript with types. This is from the official documentation. And JavaScript with types is a very strong statement. We'll not talk about it. Maybe we'll switch to the, yeah. Okay, sorry guys. So again, JavaScript with types, that gives us tooling at scale, right? This is, I did not invent it, this is what the TypeScript guys say, and tooling is actually a very important aspect of TypeScript, but I want to focus on the scaling portion, and by scale I don't mean big data or highly distributed system, I mean a lot of code. Okay, so if you're building a very big project, multiple people, many years into the project, your code needs to scale well. And what makes a code scale well, at least in my mind, is for the code to be readable, for it to have a clear structure, and for us to be able to enforce both of these topics. We also make sure that it actually does what it needs to do, right? And I'll try to talk about all of these topics and show how TypeScript helps us with all of these topics. Okay, so let's start with readability. This is a quote from, at least in my mind, the most important book in software, Clean Code by Uncle Bob. And basically what it says is that we spend much more time reading code than writing code. Obviously, if we have a lot of code, if it's hard to read, we will waste a lot of energy. So I will not go into general clean code practices right now. I strongly urge you, if you haven't already, to just read the book. But just specifically how JavaScript helps us, TypeScript helps us make it more readable. You all use TypeScript, so I'll go fast over it because you know it. If I have a function signature, and I know exactly what is the parameter type, and exactly what is the return type, I kind of know what the function does without going into the implementation. So this is very straightforward. I added here something which is maybe not all of you use, and maybe not all of you want to use, but you can also state with TypeScript that in some cases I will return, let's say, information, and in some cases I will return undefined. Okay, and now explicitly, when someone is looking at this function signature, that person knows that undefined is a possible outcome. So more functional languages, and actually even Java has a better solution for this with optional or option, or maybe if you've used those data types, which is nicer, but you can also use it like this, or introduce some functional library to your TypeScript code and just use maybe or something like that. And obviously, if you just type in any everywhere, you're not doing anything, okay? So just don't do it, okay? So let's talk about structure for a second. why is structure important in our code base? So imagine you have a closet. This one is very structured and ordered. And probably many of you are German, so that's probably how your closet looks like. But let's say you come from Israel, and it doesn't look like this. And you're trying to look for socks, and you don't remember where they are, and you look everywhere, and it takes you 15 minutes, and you end up with 2 unmatching socks, right? And then you go to the store, and you buy a new orange shirt, and you discover you have the exact type of shirt somewhere, but you forgot about it because you can't see it, right? Same things happen with our code base. If it's unstructured, it's very easy for us to get lost, take a lot of time to find things, and kind of like duplicate behavior just because we forgot it somewhere, right? So let's talk for a second how we can introduce structure. I will go to a smaller concept and build a bigger concept out of it. So let's start with a concept which I call separating data from logic. Okay, so I'm not sure if all of you came into TypeScript from JavaScript or from something like C#. So I'm not sure if you're into object-oriented or kind of like a more native JavaScript way. But let's say you're used to seeing classes that looks like this. You have data fields, and you have methods that manipulate the data. So you're encapsulating everything in one class. What I'm proposing is to separate the data from the behavior. So we have one class that just holds the data. In this example, it's a segment that has these fields. And now we have different classes that just have implementation of logic. In this example, some rule validation. And if I have other types of logic, that might be different classes. And the reason I like this approach is because of some principle. I'm sure most of you know the solid principles, right? Again, by Uncle Bob, I think you figured by now, I like the guy. So the first letter of solid is S, which stands for single responsibility principle, as most of you, or all of you maybe already know. Again, arguably the most important letter in solid. So single responsibility, very important. Now when we separate data from logic, when we think about responsibilities, we have the responsibility of defining the data objects we want to work with. And now we have the responsibility of what we want to do with them. And one way to think about single responsibility is single reason for change, if you've heard that phrase. So let's say I want to change the data, but in this example, I'm not changing anything related to rules. So rule validation class stays exactly the same. And more commonly, maybe I'm changing the behavior, but the data stays exactly the same, right? So as you can see, there's different reasons for the code to change. So by separating the data from the logic, I allow things to be the location of where I put things more clear. And if I went ahead and done that, I can actually just use types to describe the data, and I can just use functions to describe the logic. Now, I'm showing these slides because some people don't like the classical object-oriented and the verbosity of TypeScript. You don't have to use classes if you don't like them, and you can get a lot of benefit out of TypeScript as is. And you can go ahead and use classes and interfaces, and I have examples like that later. So we've talked about like a small concept, separating data from logic. Let's talk for a second about more high-level stuff. And I'm sorry for the pure front-end developers in the room. This is mostly kind of like more back-end oriented, but you can apply the same logic on the front end as well. So this is from a book called Clean Architecture. again by Uncle Bob. He's my favorite uncle, I'm sorry guys. So, Clean Architecture is a very big book. It has a lot of text. This is one image from it, but it shows something interesting. Uncle Bob suggests building our project from top down, high level to low level, where the most high level thing is the business entities I'm interacting with. So in my case, it's a segment. If I'm building a stock trading system, so maybe a stock is a core entity in the system. And this, now I'm diverging, don't tell Uncle Bob, but the book doesn't say it like this, but I prefer the business entities to just have data and no behavior around them. And now I have the use cases. This is what I do with those data entities. So if I'm in the front end and I have all the different actions and reducers and whatever, the business logic, I'm interacting with the business entities, those are the use cases. In the back end, I'll show a picture in a minute what I mean in the back end. And then I have lower level, I have things that interact with API calls, controllers, gateways, things like that. And the most low level things are external dependencies. Okay, so this is very useful to make sure that your core entities remain pure and are not affected by the logic, and then you make sure the dependencies flow in that direction. So this is something most of you probably are not familiar with. This is from a methodology called iDesign. Will not explain it in details, but basically it's a structure. You don't have to use this structure. You can use whatever structure you like. I'm just trying to show you how structure helps. So this structure says that every line in my code base either sits in an API, manager, engine, or data access, or utility, which is a cross-cutting concern, not business specific. And now I have different types of components. And they all have very clear responsibilities. So it's who wants to interact with my business entities? What do I need to do with them? How should I do it? And where do I want to store it or fetch the information from? Okay, so this is a framework for building microservices on the back end. On the front end, you mostly get this from, let's say you're using Redux, so you have the reducer, clear responsibility, action, clear responsibility. So you can just use whatever structure you like as long as it's very clear what part of your structure is responsible for what. And this is from a Node.js project, just like part of the file structure. And you can see here that I'm structuring my code base the same way we've discussed. I'm building modules that are focused around the core business entity of that module. And then inside that folder, I'm separating everything in the correct place. So data objects go here, no matter what type of data object. And the behavior is separated, as we've seen before, by who, what, how, and where. So again, if you want to kind of like learn more about this methodology, you can ask me later. Just want to show you that now, if I need to do something in my project, I think to myself, okay, what business entity am I interacting with? Okay, it's audiences. I will go to the audience folder. And now, what type of change am I trying to make? Is it regarding only to who will interact with my system? If it is, I'll go to the API folder. If it's where do I store the data, I'll go to the data access folder. So it's very clear where should I look for. And this structure is not feature-based. So when the code will change, and the code will change, obviously, the structure will remain the same. Okay? And this is a very, very important statement. Your structure needs to be such that when the code will change, your structure will remain the same. Otherwise, over time, it will get messy. So, let's talk about enforcement. This is a very funny show if you don't know it. Why do we care about enforcement? Because if we don't have enforcement, we have something like this, right? This is a common Israeli apartment. And I'm kidding. Some of us know how to clean. But basically, we've all started with new projects. They looked great in the beginning. Everything was amazing. Everything was very straightforward. And then a year passed by. Sometimes it's enough. 2 years passed by, and now it's not a nice place. Okay, so we need enforcement because developers come and go. We forget what we intended in the beginning. We have context switches. We need a way to enforce our structure. And again, German crowd, you're into this, but some of you may not be. So enforcement is important. You need to follow the rules. So this will be very trivial, so most of you, so I'll go quickly. If we have a data types, and I've mentioned I'm building everything around data types, Typescript maintain the shape of the object, right? I cannot add fields. I cannot change the fields of the object. It will be a new shape. I can also use type utilities. Again, this is some of them. I can make something read-only to enforce some behavior. I can make an optional field required. There's many different things I can do with Typescript to explain exactly what my data should look like. So on compile time, it breaks if I'm not doing things as I should. And let's talk a little about how do I enforce structure. So this is the slide from before. I want to focus just on the API portion because we don't have enough time. So I'll show two things and then I will show how they combine, okay? Sit tight. Okay, here's a pattern. This is a design pattern called CQS. It stands for Command Query Separation, not to be confused with CQRS, which is something else and much more complex. Basically, CQS says that when I have certain methods, they're either commands or queries. They're either manipulating data, mutating data, and returning nothing, or they're just like read-only and they extract data and that's it. And the reason this pattern is useful, it's very easy to the reader to see what's about to happen. And using Typescript, I can create an interface of this pattern and make sure I only use this exact behavior in my code. There are obviously a lot of different design patterns, and a lot of them are easy to be enforced with Typescript. But in some cases, there's no clear design patterns. There's a convention. So let's say I'm building an express controller in my Node.js project, or just like something that fetches API in front end. But basically I can say in my project, a controller looks like this. It has these specific methods and that's it. Now I don't have to rely on every developer to call things post and not create, put and not update. They just use the exact same convention because it's forced by a specific type. And now combining the two, when I'm implementing a controller in my code, you can see that the controller I've created, its return type is a controller. This is the convention. And the input methods to be used by the controller are either commands or queries. So I'm using this design pattern. And basically, just an example of showing you can use specific designs and patterns as types and not only your business logic. Okay, maybe some of you do CrossFit. This is called the overhead something, but I wanted to talk about, I don't do CrossFit. So I wanted to talk about the overhead of TypeScript. So I don't need to convince you. Looks like all of you are already doing TypeScript. But you might have friends that will tell you, look, TypeScript is okay, but there's so much overhead, it's not worth it. Okay, so they're right to some extent. There is an overhead, but I think it's worth it, and looks like probably you do as well. But we can reduce the overhead at least a little. So we can use type inference. Again, maybe straightforward for you guys, but we don't have to explicitly say the type of the variable in many cases because TypeScript is smart. It can figure it out. Why write code that it's not needed? It's longer to read, right? So just use it. I was a Java developer in my past, and I hated this, so this is a good thing. Use it. Don't overdo classical object-oriented. I think it's a good advice, even in object-oriented like languages, but use modern patterns that are less verbose. Prefer composition over inheritance. Like, don't create like very complex structures with TypeScript. Also, keep it simple. I talked about design patterns and conventions. If you have dozens of different design patterns, it defeats the purpose. No one will know what they mean. So in my project, every manager is using CQS. Engines usually use strategies and not, it's like different flavors. So stick to what works for you. Only use several patterns, only use several conventions. Try to keep it simple. And you don't have to create everything manually. In TypeScript, again, you probably know some of it, but let's see with examples quickly. So you can create types out of other types. You can say, okay, I have this base object. All of my objects have the same base fields. So I'll just say a segment is whatever's inside base object and this additional fields, right? I can also use key of, type of words to very quickly create types. So let's say I have an enum and I want to create type of the enum literals. I can just use key of, type of the enum, and that's it. This is from the Redux official documentation, which maybe some of you have read, and you can say here we use return type to just create the type of the state. This is the official recommendation. So TypeScript gives you ways to quickly create types out of other types. And by the way, in many cases it's good advice because in big projects we have a lot of types. We have a lot of derivative types. Sometimes we have the business entity and then the database entity and then the DTO and maybe something else, and they're all almost the same. Now I can have the core features and only add and subtract fields as I need with like omit and pick. It's like different types of TypeScript type utilities. And now if something changed, I don't need to remember where else do I use it and go all around. Things are derivative of each other and allows me to save time and reduce errors. So I've talked a lot, and thanks for, I think you're listening. So how do I know if my project is actually scalable? Maybe you already do everything I said. Maybe you do different things and your ideas work well. So how do you know? You know by asking yourself a simple question. Let's say I have a feature or a bug fix in a very big code. How much time will it take me to know exactly where to make that fix? Right? If it takes you 2 days, or you have to talk to 5 different people, your project is not scalable. Okay? So that's a very good measure. In a good scalable project, it should be very easy and intuitive to know exactly where, at least to start, right? And the other important question is, how confident are you that once you fixed something, you added a feature, it actually works, right? Because we can have an amazing project, but if we screw it up along the way, right, we lose what we had in the beginning. So let's focus on the confidence part for a second, because I've talked about the first bullet up till now. And obviously for confidence, you introduce testing, right? How many of you write tests in your code? Great, give yourself a pat on the back. This was not the case 10 years ago. Do you know this pyramid model? Yeah? Familiar? So this is how we used to write tests. Tons of unit tests, all the different edge cases. I would argue that's not the way to write efficient tests. I would argue you should do the diamond approach or the trophy approach, which means that we focus our tests on the integrations and we focus on behavioral tests that are describing the actual business use case that my project need to actually do. So let's say there's like an edge case in some small utility function, but it will never be used in production. So who cares about it, right? I want to build tests that resembles how a user will interact with my system. And this, by the way, is very powerful on the front end as well. I recommend reading things from Kent C. Dodds, if you know the guy. So basically, Typescript can help us with building descriptive integration tests. Also, introducing static tests that we've discussed on compile time. Our code will break if the types do not match. And this is from the React official documentation. Basically, it says, use Typescript. So here's an example of an integration test. Actual production bug I had. As you can see, there's a create mock segment here. And something changed in the production code, in the data. But the test continued to work because the test built the old type of data. So by introducing TypeScript, we can catch it in advance. TypeScript makes sure that my tests use the actual production code as it should be used, and not with other data. So, summary. For our code base to be scalable, we need to make sure it's readable. We need to make sure we enforce the order and the structure. We need to make sure that we're confident that it's working. And I hope I convinced you a little that TypeScript can help with all of that. And there is an overhead, but we can minimize it and enjoy both worlds. So here's 2 books, Clean Architecture and Writing Software. They'll talk in more details about the high-level structure I've mentioned. And that's it for me. You can catch me on, that's my name, Taliafe. And you can ask me questions now, I think, as well. So thanks.
Thank you, Tal. So we have some time for questions. Check out the app, ask your questions, upvote the questions already asked. So first one, how to migrate legacy projects to clean code architecture?
Okay, that's a great question. I recommend starting where it's easy. So I'm not sure who asked the question, but I would start with the peripherals, the data access or the gateways into the system, because they don't have business logic mostly. They should not have. They're very easy to create specific patterns for them, and they're usually very messy in unordered code. So start with what's easy to change, and the last thing you should change is the very specific business logic, because there you will get less benefits from like generic architecture. So I hope that answered. Okay.
Another one, what formatting and linting frameworks do you recommend for a scalable TypeScript development experience? Formatting and linting frameworks.
Oh, linting. Oh, that's a great topic. I'm not a linting expert. I use the standard TS linters. I think use whatever works for you. Most of them are great. Use the one that it's most used in the community. So when it's hard to configure, you can find it on Stack Overflow. I will probably use the most common one. They're good.
Sorry, my app is crashing. In the meanwhile, while I tried to restart again, I read that you love to listen to podcasts. So I was thinking about, is there a podcast that you can recommend when you want to hear more about the topic? Are there TypeScript podcasts to recommend?
Wow. I actually like podcasts that are not about technology because it's hard to focus when you're driving your bicycle on complex architecture. So I don't have any recommendations there, but I don't know. Sorry.
Okay. Another question. How important do you think building a complex but scalable folder structure in a world where mostly file search is used for file navigation? So how important?
Okay, that's an interesting. Everyone got the question? The question is, like, why do we care about file structure when we can just look for things, right? But you can only look for things if you know what you're looking for. And in some cases, we don't know exactly. We know kind of like in general what we want to do, but we don't know the actual name of the function or the class. So providing structure, I think, is very important because it makes it very clear where things should go. And when it's not clear, we get duplication, we get spaghetti code, we get things that are kind of like coupled from many different areas, and that's something we don't want to have.
Another question?
Sure.
What you recommend sounds like the anemic domain model anti-pattern. What are your thoughts about that pattern?
Who has that? That's a great question. Who asked that?
So who asked this question?
Okay, I don't know who asked that. It's an amazing question because it's something I wrestled with. I know it's an anti-pattern to create data without methods. That's the anemic model. I wrote a post by the refactor guy. I forgot his name. He's very well known that says it's a big anti-pattern. I don't know. Guys, it works very well for me over a lot of years. Just if you like this idea, use it. If you don't like it, don't use it. I find it to be a very useful pattern. but it's a great question.
Okay, then one last question. Regarding integration tests, do you mock the API?
Okay, guys, you have great questions. I didn't dive into it, but when I'm writing integration tests, I'm trying to mock as little as possible. I will only try to mock external things. And in that example, my own database, to me, is not external. It's internal. Okay, so if I'm calling the server from the front end, it's external. I will mock the server itself. If I'm calling another service, I will mock it. But if I'm calling something internal, especially like between different layers, I will try to mock as little as possible because I want to be confident that everything works as it should. So, by the way, if you remember the diagram I've shown before, we have API and manager. So the manager is responsible for driving the use case. So most of my tests will be calling manager methods and trying to mock as little as possible in this flow. So it mimics the actual behavior of the code. Same can be applied for the front end. Again, don't try to only test, the selector, only test the action. I want to click on something and make sure it actually does what it needs, right? So mock as little as possible.
Okay, so Tal, thank you very much for being here.